Today, we're going to break down a really powerful new framework called MAGNEO. It's designed to solve some of the most mind-bendingly complex problems you can imagine. But here's the cool part. It doesn't just use brute force. Instead, it kind of approaches these challenges like a sculptor, carefully shaping the perfect solution out of a whole universe of possibilities.
So think about this for a second. Let's say you have to plan a delivery route across the country, or design a super complex computer chip, or even build a new communications network. You're not just looking for a path that works, you need the absolute best one. But when the number of choices explodes into the trillions, and I mean trillions upon trillions, how on earth do you even start to find that single perfect answer?
Well, that question drops us right into the world of combinatorial optimization. It's a whole field dedicated to finding the best possible solution from a set of possibilities that is often just astronomically huge. And to really get a feel for this, there's one famous puzzle that's the perfect place to start our quest.
Right. Let's talk about the traveling salesman problem, or TSP for short. It sounds so simple, doesn't it? Just find the shortest possible route that connects a list of cities and visits each one only once. But here's the kicker. With just 50 cities, the number of possible routes is, well, it's a number so big it's hard to even comprehend. We're talking more possible routes than there are atoms in the known universe. Yeah, really. This is what's known as an NP-hard problem, and it's exactly the kind of impossible quest that has had researchers scratching their heads for decades.
So why is this so tough? The traditional ways of tackling this have some serious drawbacks. It's all about setting up rules, or penalties, to guide the process. But these penalties often end up in this constant tug of war. If you make them too harsh, the whole thing just breaks. Too soft, and they don't do anything. The answers get stuck in this fuzzy maybe state, not a clear yes or no. And worst of all, they totally lose the big picture. You end up with a bunch of tiny, disconnected loops instead of the one single perfect tour you were looking for.
Okay, so if the old methods are constantly getting stuck in the mud, we clearly need a new way of thinking. And this is where the story pivots from the problem to a really, really elegant solution. Let's talk about the philosophy behind MAGNEO.
The whole idea is built on something called continuous relaxation. Now, stay with me here. Instead of trying to deal with trillions of separate yes or no choices, what if you could transform the entire problem into a smooth, continuous landscape? Think of it like a giant block of clay. From there, you can use the super powerful tools of calculus to gently shape and mold that clay, pushing and pulling it until it forms the perfect answer. You're not checking every single option, you're sculpting the single best one.
And this brilliant sculpting approach, that is the very foundation of MAGNEO. It's a brand new framework developed by independent researcher Mohammed Ben Amar Turedi. His work gives us this general-purpose engine that's designed to take on these impossible quests head-on.
So how does MAGNEO actually do this sculpting? It's not magic. It uses a really clever combination of three guiding forces that all work in harmony to shape the final solution. This right here is the heart of the whole innovation. The process uses three totally distinct adaptive penalty streams. First up, you have the rule enforcer. This is a structural stream that just makes sure the basic rules of the game are followed, like visiting each city only once. Then you've got the big picture guide. This is a spectral stream, and its job is to make sure the solution is one single connected loop. And finally, you have the decision maker. This is a contrastive stream that comes in and pushes all those fuzzy maybe answers into clear final yes or no choices. It's what reveals the final statue from that block of clay. And this is the absolute key to the whole thing. Older methods use these rigid, fixed penalties. It was a one-size-fits-all approach, and it just didn't work. MAGNEO's penalties, on the other hand, are adaptive. They're dynamic, they're reactive, they are constantly adjusting themselves based on what the solution looks like at that very moment. This is how it maintains a perfectly balanced competition between all the forces trying to shape the answer. Okay, that all sounds fantastic in theory, right? But does it actually work in the real world? Well, let's see what happened when MAGNEO was unleashed on the classic traveling salesman problem using a set of standard test cases from a research library called TSPLIB. The results are, well, they're pretty stunning. On some of these benchmark problems, MAGNEO found a route that was within 0.01% of the known perfect answer. For this kind of problem, that level of precision is just incredible. And when you compare it to other common methods, its power becomes even more clear. Going up against standard techniques like nearest neighbor or greedy edge, MAGNEO consistently found solutions that were 7 to 12% better. Now, that is not a small incremental improvement, that's a huge leap forward. And maybe the most impressive thing of all is how it gets these results. This quote from the paper is really important. Magneo gets this amazing accuracy purely through its continuous sculpting process. It doesn't use any of the traditional little cleanup tricks or post-processing hacks that other solvers rely on to polish their messy results. This is just the raw, unassisted power of the framework itself.
But look, this is about so much more than just solving one kind of puzzle. The real power of MAGNEO is just how versatile it is. The framework was designed from the ground up to be a general-purpose engine for all kinds of these so-called impossible quests.
So why is this such a game changer? Well, first, the core engine is what's called problem agnostic and totally modular. You can just plug in the rules for a brand new problem and it's ready to go. It's also transparent and interpretable, which means you can actually see how it's working. It's not some mysterious black box like a lot of AI. And crucially, it's one of the first frameworks to successfully embed these really complex, big picture rules directly into the optimization process itself. The potential applications here are just vast. I mean, think about optimizing entire fleets of delivery vehicles, designing way more efficient communication networks and computer chips, or even tackling incredibly complex problems in machine learning. Basically, any field that runs into these massive combinatorial headaches could benefit from this new way of thinking.
And that leaves us with a final, really fascinating thought. The old way was to try and search through an impossibly huge universe of different options. MAGNEO shows us that instead, we can start with a formless block of pure potential and just sculpt it into the one perfect solution. If we can do that, what other problems that we've always considered impossible are suddenly within our reach?